In this video, buck and boost converter, which is based on TL494 IC, and the voltage input from 12 volt to 24 volts, and the output is from 1.5 volt to 80 volts with current control. So this is the back side of the PCB, which is and it's a MBR2000 schottky diode, and it's a IRFZ44N Mosfet, and it's a ATX supply DC output filter. So I don't modified it, just connected the coils, and these are the voltage and current control potentiometers, which can be used for adjusting the current and the voltage. So I'm powering with the 12 volt DC. So the LED on the circuit is indicating the power on, and the volt and ampere meter I am connecting at the output, so that we can see the voltage and current at the same time. Now the circuit is basically current and voltage control mode. So if you want to charge any lithium battery, so you can charge with constant current from 3 volts to up to 80 volts. And now you can see on the meter it's 12.6 volt at the output, and I'm connecting connectors so that we can connect the output for the experiments. Now you can see I'm sorting the outputs, and you can see on the meter it's 12.6 volt, and the current is 0.4 amperes. So first we can see the voltage regulation. So the voltage can be vary from 1.5 volt, and the minimum we can achieve is 1.5 volts. So it's a very usable voltage for low voltage electronics, like testing the LED or any kind of microcontroller based projects. As you can see, it's a 1.4 volt minimum we can get from this circuit, and the maximum we can achieve from this almost 100 volts, but we are going just at 80 volts because the capacitors I have connected is maximum of 80 volts. Otherwise the capacitor, if you use maximum volts, and also I have testing the circuit, it can maximum boost the voltage up to 130 volts. So you can see the spark at the short circuit at the output, and the current is constant. So the voltage is 80 volts, but the current at the output is we can adjusting from 40 milliamperes. We can adjust minimum current is the 40 milliamperes, and you can see the voltage is 80, but the minimum current at the output is almost 40 amperes. That's 0.04 amperes. So we are going to adjust the output current, and first we have to down the output voltage, and you can set the output voltage as any volts as your requirements. And you can see the I have sorting the output leads, and now I'm adjusting the current using the current control potentiometer. As you can see, the current is controlling and increasing very smoothly, and the precision of this potentiometer is also very high. So use multi-turn potentiometer for the high accuracy, and you can see the current is maximum we can achieve from this circuit is at 5 amperes. And the voltage is 9.3 volts now, and I'm testing this 12 volt to LED. So the voltage I'm setting 3 volts. Now increasing the voltage for the requirement of this LED up to 12 volts. and like this we can adjust the output voltage and increasing the output voltage. Also the LED is glowing a little bit dim. Now I'm increasing the voltage more, but the current I'm letting down, but I am increasing the voltage, so I'm decreasing the output current as the LED brightness becomes low, because the minimum current is 40 milliamperes, and this LED consumes maximum of 100 milliamperes. So the brightness of at 40 milliamperes like this, and when I increase the current limit, then the LED goes into full brightness. And now it's turned to testing this high power motor, which is also known as 775 DC motor, which can be driven up to 34 volts. So the voltage is 11.6 volt and the current is 0.4 amperes. And I decreasing the current limit, you can see the voltage at the output is also decreasing, but the minimum we can adjust is 0.4 or 0.04 amperes. So the circuit is working as I expected, and you can also check the circuit and PCB of this circuit, which is given in the description. And if you have any kind of doubt related to this circuit, and you can ask your any kind of doubt in the comment. So the basically this IC TL494 IC have two comparators, and I'm using one comparator for the voltage controlling, and second one is for the current controlling. And also I'm using the 0.255 watt resistor and at the output, and I for the high power I connected the two resistor in parallel. So the voltage drop on the resistors, which is also known as shunt resistor. So according to the shunt resistor voltage drop, we can adjust the current at the outputs. And the circuit is efficient at in my case up to 83%. So the maximum we can achieve more, but for now it's for me maximum the efficiency is 83%. And this is the second part of this video, as in my earlier first part video I have shown the PWM controller using this TL494 IC. So thanks for watching, and I'll see you in the next video.